Good afternoon, friends. Now we are studying the basic property of fluid. So, capillarity. So, it is the phenomena of rise or fall of a liquid surface in a small tube relative to the adjacent general level of the liquid when the tube is held vertically in the liquid. That means a glass tube is immersed in a tank which is filled with some liquid. So as soon as this glass tube is immersed in the liquid, some of the liquid from the tank will get raised into this glass tube. So this phenomena of rise or sometimes there is a fall in the level of the liquid in the glass tube. So that phenomena of rise or fall of the liquid surface in the small tube relative to the adjacent level of the liquid. So the level of the liquid in the container is here and the level of the liquid in the tube is this. So the rise of the liquid surface is known as capillary rise. If it is the fall of the liquid surface, it is known as capillary depression. So this capillarity is expressed in terms of centimeter or millimeter of liquid because the rise or fall of the liquid is measured in terms of so many centimeter or so many millimeter of the liquid. So its value depends upon the specific weight of the liquid, diameter of this glass tube and the surface tension of the liquid. So all these factors decides the phenomenon of capillarity. Now, so there will be a small derivation for capillary rise. So consider a glass tube of small diameter d opened at both ends and it is inserted in a liquid, say water. The liquid will rise in the tube above the level of the liquid. Let h is the height of the liquid in the tube. So this h is the height of the liquid. So with respect to the adjacent level of the liquid in the tank. So now uh, under the state of equilibrium, the weight of the liquid of height h is balanced by the force at the surface of the liquid in the tube. So that the force at the surface of the liquid in the tube is due to surface tension. So we mean to say that here, so whatever liquid present in the glass tube, its weight is maintained by surface tension. So that surface tension phenomena we are going to discuss now later. Now let sigma is the surface tension of the liquid. So theta is the angle of contact between the liquid and the glass tube. The weight of the liquid of height h in the tube is nothing but so my weight density is equal to weight by volume. So volume of the liquid is now area of the tube into height of the liquid in the tube into its density. So that is rho. So surface tension. So here, so I have the meniscus here. So this meniscus formed is due to surface tension sigma. So this is making an angle theta with the vertical wall of the glass tube. So theta is the angle of contact between the liquid and the glass tube. So now, so area of the glass tube is now pi d square by 4 into h. So that is height of the water column in the tube. So into weight density. So that is rho into g. So mass density is rho, weight density W is equal to rho into g. So weight density is equal to weight by volume. So weight is nothing but now weight density rho g into volume of the liquid. So where rho is the density of the liquid. Now the vertical component of the surface tensile force. So if you see the figure, so this sigma is an inclined force now. So the vertical component, if we split this inclined force into its horizontal and vertical component now. So that is here we have sigma into its circumference into cos theta. So circumference is now pi d into cos theta. So it is sigma cos theta is the vertical component. So if you take, sorry, so if you consider this capillary rise, so it is making an angle theta here. So the vertical component is now along the wall. So this is sigma cos theta, and this is my horizontal component. So that is sigma sin theta that we are not considering. So this sigma cos theta is the vertical component of this force. So that is sigma. So we are so since this is sigma is making an angle theta with the uh, circumference of this glass tube, so we are taking here circumference into picture. So that is uh, we have so sigma into pi d into cos theta, because we know that here the force is equal to, so here the pressure by area here, so it is force into area. So here force is now sigma into cos theta, so area is nothing but here the circumferential area, so that is pi into d. So this vertical component of the surface tension is making this liquid to stand in the column. Because of this surface tension, so the liquid column is standing. Otherwise, whatever liquid which is raised in the glass tube will fall back into the container. So the liquid which is raised in the glass tube is standing in the glass tube itself uh, by maintaining the surface tension here. So that two forces now we are equating so that the surface tensile force is balancing this the liquid of height h in the tube. So equating these two equations what we have now, so we are getting the expression of capillarity h is equal to 4 sigma cos theta divided by rho into g into d. Simplifying numerator and denominator, we are getting the expression of h as 4 sigma cos theta divided by rho into g into d. Now if we take a water and a clean glass tube, so the angle theta between the glass tube and the water, so what you are seeing this theta in the picture, so theta is almost equal to 0. So if you take cos 0, so that is equal to 1. So we have left in the equation h is equal to 4 sigma divided by rho g d. So that is the expression of capillary rise. Similarly, we have the expression for capillary fall. Now we are taking mercury in the tank. So now the mercury is heavier than the glass molecule. So that's why even if the glass tube is immersed in this mercury, so there will not be any rise of the liquid in the glass tube. So there will be a fall of the liquid. So that is known as capillary depression or capillary fall here. So we have now h is the height of depression in the tube. Now then in equilibrium the two forces are acting on the mercury inside the tube. So as usual, as we have taken in capillary rise, we have the equation here. So that is due to surface tension sigma into pi d into cos theta. Now it is the hydrostatic force which is trying to push the glass tube upwards. So that is this. So finally we have the expression for capillary rise h is equal to 4 sigma cos theta divided by rho g d. Thank you.